Okay, so each of these dots here represented a student, right? A student whose height and shoe size were measured, right? So we saw each one of those. That's why each of those dots is there. And then we said that so that's what each of those dots represents. And then the line represented something different, okay? Because the line, remember, any line is just a bunch of dots so close together that it looks like a line. So what did the line represent? The estimated or the predicted values. Yep, the estimated or the predicted values. So this person right here with this dot here, that actually happened. There was a person whose shoe size was this and whose height was this. Okay, same thing with this dot, same thing with that dot, same thing with that dot. Those actually happened. The blue line didn't happen. Okay, the blue line is what we predicted it would happen. Well, some of the dots are pretty much on the line, some are off. Okay, so you see this little blue dot right here, that one's pretty much on the line. So that guess, that prediction was pretty close to what we expected. Same thing with this dot, and maybe this dot down here. Okay, and then the rest of them were off a little bit. So the distance between the dot and the line is what we call a residual. Okay, so the distance between here and here, from this dot, from this line to this dot, the y value, that y value is a residual. Okay, so that's what it is visually. Now, mathematically, it's the same thing, but we do a little differently, right? We have to figure out what actually happened. What was the y value of what actually happened? Minus what would we predict it would be? And we subtract them and we get a number, which is called the residual. Okay. So when do we get negative residuals? So let's look at the graph here. When do I get negative residuals? When it falls below the line. Yeah, when it falls below the line, it's going to be a negative residual. What caused that to happen? What caused it to be negative? It's less than what we predicted, right? It's less than what we predicted. So for someone who has a shoe size of, I don't know what this is. I don't have a scale here, but for someone whose shoe size is this right here, I would predict their height to be right here. But it didn't quite make it there, right? That person is under what I estimated. So if they're under what I estimated, that means their predicted value is smaller, right? Yes, sorry, I got it right. Yeah, predicted value would be higher because that's the line, right? So a question they usually ask on tests, or a lot of times they ask on tests, is when is a residual negative? When is a residual positive? Well, when the actual is smaller than what I predicted, it's negative. When the actual is bigger, yeah, higher or bigger, then it's positive. Okay. All right. And then we actually found the residual for some. For a shoe size of 7, there were 3 people whose shoe size were 7. We found the first one, we found a residual. It was negative, it was underneath the line. The residual for the one person who had 10.5 was negative 1.422. Okay. All right. Okay, so what we can do now, this is what we're going to do. We're going to do this in a second. Is on our calculators, we'll do this. Let's create what's called the residual plot. A residual plot is a scatter plot, but it's not this scatter plot here. This is this original scatter plot with all our data. What the residual plot does is it measures the X value versus each of the residuals. Okay, so ours isn't going to be tree age because ours, what was our X in the data we have? shoe size, right? So ours is going to be shoe size, right? Start with whatever shoe size goes up to whatever shoe size, right? And the residual will be like this, okay? So we have, I think there was 31 dots on here. I think there were 31 on here. We found residuals for 2 of them, right? The green and the yellow, we found residuals for. It's not hard to do, right? It wasn't hard to do that. We plugged it in. We got the Y value minus, then we plugged in the X and got the Y value again, right? So like for a person, so for like a person who has the next person, this person right here, this person right here, what would their residual be? What would their residual be? This person right here. Can you calculate me what that residual would be? The top one.
Negative 1.8%.
Yeah.
Is that what you guys said? Didn't you do this in stats?
Do what?
Like all the calculations?
That's what we're gonna do next, yeah.
You just do L3, then you put the bar in it, and then set X.
You got it. Yep.
L3, L2.
That's exactly what we're gonna do here in about 2 minutes. Okay, so sorry. Anyone else get that?
You guys have pauses?
I asked the wrong person.
I'll do it in
848. Okay. Yeah, it's close enough. Okay, and then what was the 10? What was the green one? It was written on our paper. 422. Thank you. And this was this one, the yellow one, negative 0.305. Is that right? Okay. Okay. So what we need to do is I need to do that for all of them. How many are left? 29, right? It's not hard to do, but it's tedious, right? It's just tedious. It takes a while. Well, that's why we got the calculator. Guess what? The calculator will do it faster than any of us can do it by hand. We just have to tell the calculator what we're going to do. Okay, so we're going to calculate the residuals, all the residuals in one fell swoop. Okay, so go to your calculator. Hopefully it's a calculator that was used yesterday. So L1 and L2 are in there. Or else you have to rewrite everything. That's why it's nice having your own calculator. So it's always in there. Okay, so you need the data in L1 and L2. Okay, that's the first thing. Make sure all of it's in there, because if it's not in there, this won't work. Okay. So how do we do it all in one swoop? Well, we're going to go to list 3. You kind of saw on my list, I was making another list, right? On my notes, I was making a 3rd list, right, for residuals. I'm going to do that, exactly that, but I'm going to have the calculator do the heavy lifting. Okay. Okay. So I need a 3rd list. So what you're going to do here is when you want, I'm going to give it a command though, because I don't want to have to type them in one by one by one by one. So anytime I want to give the calculator a command, I go up to the top and I hit either clear or enter. Wait, no, enter. Yeah, enter. When the calculator is ready for that command, it'll have a little blinking cursor down at the bottom. That means I'm ready. Okay. How do we calculate a residual? I know a residual is y minus y hat, which is actual minus predicted. Okay. So what I'm going to do here is I'm going to do this subtraction problem for every single one of those numbers, for every single one of these guys in one swoop. Okay, so what are my actual? What do I put in? What do I use for actual? Yeah, list 2, right? It's always these numbers here. It's always the numbers in list 2, the y, right? So what I'm going to do is I'm going to tell the calculator, okay, all the L2 values. So L2 is right above regular 2. You just got to hit second. And then I subtract, right? What do I subtract? The equation, right? I need the equation. So what I'm going to do here is, since it's an equation, I'm going to put parentheses. And then let's go find the equation. We did this yesterday. Hopefully the calculator remembers what my equation is. If it doesn't, we'll just calculate it again. So remember, it's in vars. Down the statistics. Over to EQ for equation, and then the top one. Does it remember? It does. Wow. If it did, let's say it didn't remember. Let's say it didn't remember. How would I get the calculator to remember these numbers again? Yeah, how did you calculate these numbers to begin with? How did you know that this was A and this was B?
You rewrite list 1 and list 2 with that calc.
There you go. You just go find A and B. But you don't have to put the numbers in because your calculator, you have the numbers in there, right? As long as you have the numbers, then you have to put the numbers in. Yeah. Then you have no. Yeah. If we already have the numbers in there, then we don't have to do that. But obviously we do. Yeah. Okay. Okay. So we used our equation, and then what did I do to the equation? I plugged it in. Where did I plug it in for? Now y hat. Where did I plug in the numbers to find the residuals? These guys right here. How did I figure out what did I plug? What I plugged what into what?
Plug L1 into X.
There you go. I plug L1 into the place of X. All right. So what I'm going to do here is I'm going to backspace. So I'm right on top of X parentheses. I'm going to put parentheses around it. And I'm going to say, hey, I want you to plug in L1 numbers in there. Close parentheses. I'm going to double close parentheses since I had an open parenthesis over there. Hit enter. Right. Just like that, we have all of our residuals for every single dot. Yeah, in stats, we use the calculator for everything. In calculus, where people think you need a calculator, like I haven't used a calculator once in calculus because you can't. You're not allowed to. In calculus, there's like 70% of the stuff is no calculator. And the other 30%, it's like two or three functions that you use. So it's not a lot. So yeah, in calculus, but like you don't need to do these things. It's different. Yeah. So yeah, and definitely in stats, calculator is more important than calculus, which is odd because you think calculus, it's got the word calc in it, but no. Anyway, so getting off task. Here we go. So we noticed the first one, right? 1.84748. We said that earlier. 10.5 is negative 1.422, which we did yesterday. The first 7 is negative 0.305, which we did yesterday. So those make sense. So the rest, so now you can see which dots are above and which dots are below, right? which dot had the biggest residual? Scroll down and see which dot had the biggest residual. Shoe size 7? There you go. Shoe size 5, 69. That person right there, why is their number so big? So in common, like in context, what does it mean? That person, no. Yeah, okay, but in context though, means don't sound like a statistics textbook. Sound like a regular person. What does that mean? What about their shoe size and their height? There you go. There you go. Yes. Yes. That person, for how tall they are, they have a small foot, right? They have a small foot. That's what that means, right? So what about the smallest residual? Here's a -8 point something. So -8.843, this person right here in context, so sounding like a normal person, not a statistics textbook. What does 654, what's significant about them? For being so, not necessarily, that's 5'4", so they have a bigger foot for being not as tall.
That's 54.
Is it 4 something? 4'6", yeah, 4'6", 4'5", 4'6". So 4'6" is like, you know, and they have a size 6 shoe, right? That's what's significant about them. Okay, so go back to the top. Okay, so now what we're gonna do is we're gonna graph, but I'm not gonna graph L1 and L2. I'm gonna graph a residual plot is X versus the residuals. X versus the residuals. So our X is in L2, our residuals are in L3. So go to a scatter plot. And then instead of L1 and L2, it's going to be L1 and L3.
Oh no.
And you get some, should get something that looks like that. Okay, that's a residual plot. Now, what is a residual plot? Well, I told you what a residual, it measures each of the residuals, right? So the ones that are far away from 0 are the residuals that were really big, right? Or really small. So the one up here, this person up here, was that person who had the positive, that big positive residual, 7 or 8. This person down here is that person who had the really small, -8. Okay. And then most of the people are in the middle somewhere. So this is what a residual plot tells us. It tells us if our equation, what do I mean by equation? This equation right here, my prediction equation. Or what is it? Right here, this guy right here. The prediction equation, which I've been using quite a bit. Is it reliable? Is it safe to use for a prediction? Okay, so how do I know that? Well, you look at the residual plot and you ask yourself one question. Is there a pattern here? Do you see any type of pattern in the dots? The way they're moving, are they predictable? So if this thing continued, would you know what the pattern was doing? They're clustered, right? They're clustered. So look at your notes. I give you some examples of what a pattern looks like. if you look at, okay. So here is what I'm talking about for patterns. Now these patterns, like these are kind of like not real world patterns. Look how the parabola is like perfect, right? Look how the little wave is perfect, but those are patterns, right? This is what we want, a scattered mess, right? A mess is actually good. So which one does this fit in? One of those patterns or a scattered mess? Scattered mess, right? So for linear regression, a scattered mess is actually good. It means the equation we came up with earlier, yesterday, is appropriate. It's appropriate. It works. It's reliable. Okay? No pattern is good. Linear model is appropriate. It means that equation is okay to use. It's safe to use. If we got one of these guys, it would mean that, hey, the equation is not appropriate. It's not best to use. Why? Why would that be? Okay, so look at the first pattern. Starts out with residuals being really far off, right? Or really big residuals, right? We got residuals here that are really big, and then they get closer and closer and closer and closer and closer to zero, right? Some are even zero. And then it gets farther and farther away, and then it gets closer to zero. And then what happens as I go this way? Farther and farther away from zero. So a zero residual means my prediction was perfect. If I'm going to continue going up and up and up and up and up and up, how is my prediction going to be? Way off and getting worse. That's not okay to use. That's not okay. That's not appropriate for what we're doing, right? How about this guy here? Down comes kind of close. And then what happens here? It gets worse again, right? We want something, a perfect world would be all of our dots very close to zero. Perfect world. That means, hey, all of my predictions were pretty close on. And that's actually what happens in ours. In ours, clustered, right? They're clustered towards the center. That's good. That's what we want. That means all of them were pretty good. The closer those blue dots are to that middle black line, the x-axis, means it was a good prediction. It was a good predictor. Okay. So for this guy here, I would say a linear model is appropriate because there's no pattern in the residual plot. Okay. All right, let's see. Let's see. Anything else before I move on? Okay, so now, okay, so go to the problem that's right after this. It looks like this. It talks about ice cream and temperature. Okay, so now I'm going to give you some time to practice on your own. So do A, B, and C. Don't worry about D. D we'll do together because it's R squared. We haven't talked about that. So I'll give you about 5 minutes to do, or maybe 10, because B is going to take you some time because you're going to do it on the calculator, but it'll take you a little bit of time. Okay, so A, B, and C. So which one is explanatory? Which one's response for the problem that you guys are doing? Temperature is explanatory, ice cream is response. Yeah, they're trying to see if the temperature affected how much ice cream they sold. So for the residual plot, just do like how a scatter plot, like how you guys usually do for regular scatter plots, where you label X and Y, and then give me an overall picture for letter B. So if you're stuck with B, I'm going to do the steps right now on how to do a residual plot. So if you're stuck on how to do that, I'm going to do the steps one more time. And then if you're stuck again, you can listen to the video on your own time. Okay, so here we go. So to do a residual plot, well, first of all, you need all of the dots, all of the points in L1 and L2. That's the first thing, obviously. The second thing is you need to make residuals. So I'm going to go over to a new list. I'm going to hit enter so that it's blinking down there. That means it's ready for a command. Now we said residuals are actual y's minus predicted y's. So my actual y's happen to be in L2. So I'm going to go second L2 or second 2, which is L2, minus parentheses. Oh, that's going to do something. 89. All right, let me go. Okay, so I got to recalculate everything. So what was it, 89? Thank you. All right, everything else good? Stat. So I got to recalculate A and B. Yes, yes, yes. So my A and B, oh, that's going to change it quite a bit. So my new A should be negative 3.3. And my new B, my new slope should be 5.775. Yeah. Okay. Good. So does that match what everyone got? Okay. All right. So let me go back to what I was doing. So yeah, because if you don't have those correct, everything else is going to be off. So I'm going to go back to the same thing I was doing. So command, and then I want L2 because that's where my y's are, minus parentheses because a lot of stuff are going to be going next. So I want to make sure that they do what's inside the parentheses before they subtract. Subtraction, I want the last thing to be. So I need my regression equation. My regression equation, I just calculated A and B. So now my calculator remembers it. So to go retrieve it, you're going to go to vars, down to statistics, over to EQ, regression equation. And there it is there. Now, how I came up with my y hats with my predicted was I said, everywhere there's an X, no, don't put an X, put in an X value. And those are in L1. Close it twice because I had a big parentheses and then close the inside parentheses. Enter. And there's my residuals. So it looks like the first dot has the lowest residual. It's going to be way below the line of best fit, the regression equation. And then it looks like 15 over here. This one is a under prediction, right? That's an under prediction there, 15, because I predicted too low. This one is an over prediction. Negative 18 is an over prediction. I predicted too high. Okay, so now I need a graph. I need to graph my X values. So stat plot. So I want to list X values, which are in L1. And my residuals now, not my Y's, my residuals, which are in L3. Okay, zoom, stat, and there they are. So on your paper, just a quick just label what the x-axis is, label what the y-axis is, and then just kind of give me your own rendering of that. What's that? Check y equals. There might be something in y equals. Is there anything in y equals? I'll take a look at it in a second. Okay, so that's your that's what I need you to for letter B. Okay, and then once you're done with that, letter C, and then you're done. That's it. Zoom. There you go. There was two graphs that were on at the same time, and that's why. So when you go to graph here, this is the only one that should say on. The rest of them should say off.
Oh, did one say on?
So this one was on. So it
Oh.
was to graph both of them at the same time. That's why. Yeah, that's usually what happens where there's another graph either in y equals or there. If your graph won't cooperate.
Okay, so the problem with hers was that there were two graphs on at the same time?
Yeah, when if you go to stat plot and you know how, watch, I'll show you right now. If you go to stat plot and then some of them say at the end on and off, on and off. The only one that should say on is the one you want to see. So this one says on right here. That's the only one I want to see. Off, off, off. These two are always off and on, but 1, 2, and 3 should always be only one of them on. Yeah, 'cause sometimes if you turn both of them on, it'll graph both of them at the same time. And if it does that, then your axes get all messed up because it's trying to fit two graphs on the same time. That's the biggest, that's the number one issue. The number two issue, sometimes if your graph is not cooperating, it's this y equals here. If there's a line in here, again, it wants to graph both of them at the same time. And it's not good if it's not going to do what you want it to do, I should say. If it's trying to graph both the same. I just want to focus on just that one, that's it, nothing else.
Don't have models. Have you tried turning it up down again? Okay, well your L3 is all jumbled up. Yeah, your L3 is all jumbled up. I don't. They're way in the negatives, like -4 or 5,000.
Okay.
How do I do letter C? It's kind of different. They give me the residual, they give me the answer. I have to figure out how many pounds.
That was a thing.
How do I do that?
I put 95 into the residual formula.
Uh-huh.
I pick that answer.
Uh-huh.
I just added 6 to it because I residual 6. So the prediction was 100.
Yeah, that's it. Yeah.
You get.
Yeah.
I rounded up to 2.
Yeah, that's exactly what you do. Another way to do it is just use the formula. The formula is residual equals y minus y hat, right? Okay, so which ones do we know? We know the residual, so let me change that one. I'm going to erase that one and I'm going to put 6.214.
You can calculate the current if you predicted if you use 95 inside the.
I can calculate this right here. So I'm gonna plug in, let's see, so it's 160.276 plus. So instead, I'm gonna put 95 in here, whatever I get as an answer. What do you get?
216,744. And then you just solve for it.
Make this bigger. Then that's just gonna leave one variable, right? So anytime you just have one variable, you can solve for it just using algebra. That's my A and B. That's my line of regression. My oh, sorry. Whoa. Yeah, I didn't change mine. I did them wrong initially, and I didn't change it down here. Yeah, mine are.
Put the 8 first.
Let's see. Yeah, because I didn't. Yeah, exactly.
Well, B has the right answer, and I got the same as him. Like,
So what was A? What did you guys get for A?
I don't remember.
Negative something? 148? Right on the dot? Yeah, but in the raw number.
147.
147.45, 147.45. Now, yeah, of course you would round up because it's talking about ice cream. So you can't have partial ice cream, right? So you would round up to 48. That would be my finished answer, but I want to get the raw answer on here. So that means 148.
Oh, you can get 4.5 with an ice cream. You just get less than that. Just get a single split it evenly.
So guess what? You could, right?
You give them like less than a food.
But if I go to an ice cream store and I say, give me 0.45, they'll be like, okay.
Yeah, true.
But what are they going to charge you for? A full one, right? There you go. They just can't wait, right?
The art of the rule.
So let me change this to. Let me change this to. Three, 9. Okay.
Please excuse this interruption. Seniors, there's about 128 seniors that have not taken their yearbook picture.
What a shame.
Please sign up tomorrow or Friday for Monday's pictures. Once again, seniors, please sign up so we can make your year and the yearbook the best we can ever have. Thank you.
So you're going to add 216.74. That's the right number, right? 216.74. To both sides.
You plug 95 into the equation at the top.
Yeah, right here. Okay. Add 216 to both sides, or 216.744. And what would you get? 216, no, 217.
220.
No, sorry, I didn't line up my decimals. 220?
222. 0.998. Or 9.
Okay. So how many pounds of ice cream are sold? Yeah. You can round it up to 2. Okay. Again, froyo maybe. So yeah, so that question was just kind of backwards, right? They gave you enough information, but they just didn't give it to you the way you're used to seeing it. So you kind of had to use your critical thinking to figure it out, but it sounds like you guys are all right with that. Okay, R squared, don't worry about R squared, we'll do that next time. Okay, yes, you've seen that number a bunch of times, we just skip it.
I wrote it down.
We'll talk about it tomorrow. There will be an assignment.
But there's nothing we went over that was new.
Last time there was.
There was nothing new.
Always.
Yesterday we did nothing wrong.
Okay, I'm supposed to forget.
It's dusty.